Good evening, students of class 12. Let us continue chapter 2. In this video, we shall solve certain numericals on capacitance. Today, I have picked up few numericals based on series and parallel connection of capacitors. Fine. So, let us read the question first. Three individual capacitors C1, C2, C3 of capacitance 6 microfarad. In such questions, as I always say, there is no time for you to read the complete question. So whatever comes first, write it down. Fine. Each are connected to a 12-volt battery as shown. So potential V is equal to 12 volt in the circuit. Find the charge on each capacitor. So there are three capacitors. So they are asking us to find out Q1, Q2, Q3. That is the query. Now, once the given is understood by us, let us go to the circuit diagram. So this circuit diagram is having three capacitors C1, C2, C3 of 6 microfarad. And 12 volt is the source potential. Fine. Okay. So now let us see how to approach such question very easily. There are so many ways given in so many reference books and textbooks. But you follow one pattern for such questions, which is the easiest. So whenever such questions are asked based on capacitance and or in series and parallels, find out the equivalent capacitance, step 1. Step 2, using equivalent capacitance, find out the total charge. Then we will see what capacitors, which capacitors are in series, in parallels, and accordingly how to arrange the charges. Fine, these are the steps. So step 1, let us first find out what is the equivalent capacitance. For that, which capacitors are in series and which capacitors are in parallel. So for that, start from the battery, go up. I will use another pen, go up. Here there is a junction which is going in two ways. So it is understood that these two portions are in parallels. Fine. This portion has C3, this portion has C1 and C2. So this line is parallel to this line. Okay. So here I redraw. This is the junction which is looking like a T junction. Whenever there is a T junction, both the branches are in parallels. So it is hence understood that the charge which was Q is distributed into Q1 and Q2. This branch will have Q1 because both C1 and C2 are in series. As you can see, Q1 is passing through both C1 and C2. This branch will have a charge of Q2. Fine. Okay. So our doubt is clear that which combination is in parallel, which combination is in series. We can see C1 and C2 are in series, and the answer which we get from C1 and C2 is parallel to C3. So what is C equivalent? C equivalent is C1 to parallel to C3. So we get the equivalent capacitance as C12 plus C3. In parallels, you add up the capacitance. So C12 plus C3, because this side of the branch and that side of the branch are in parallels with each other. Now what is C12? C12 is a series combination of C1 and C2. Okay, I'll just write series so that you understand. Series combination of C1 and C2 whenever there are two capacitances. For the getting the series answer, just you follow the formula C1 C2 C upon C1 plus C2. Substitute the values. 6 into 10 raised to minus 6 multiplied by 6 into 10 raised to minus 6 divided by 6 into 10 raised to minus 6 plus 6 into 10 raised to minus 6. So you can see here that we get, even if you don't write 10 raised to minus 6, it is fine. You will get 6 into 6 into 10 raised to minus 6 divided by 6 plus 6. However maths you want to do, you can do, which is equal to 36 upon 12 microcoulomb. So microfarad. So C12 is equal to 3 microfarad, which we will place it here. C3 is already 6 microfarad. So our equivalent capacitance will be, just now we got 3 plus 6 is equal to 9 microfarad. So we are ready with the equivalent capacitance, 9 microfarad. So step 1 is done for such questions. Step 2, find out the charge, total charge, net charge in the circuit. So it is equal to C equivalent into V. What is C equivalent we got just now? 9 into 10 raised to minus 6. What is V? We have 12. So answer is 108 microcoulomb. So our step 2 with Q is equal to 108 microcoulomb is over. Done. So it means the total charge is 108 microcoulomb, which is distributed into Q1, Q2. Fine. Okay. So once we get Q2, it is easy to get Q1. Just minus it off. Any way you can do, but this is an easier method. Fine. Okay. So we can do it in different methods, but let me teach you one method, which is the ratio method of capacitance. Fine. So let us now learn the ratio method of finding out the charges Q1 and Q2. Now in this branch of C1, C2 in series, we had C12 is equal to 3 microfarad. C3 was already given to us as 6 microfarad. So find the ratio of 3 and 6. 3 is to 6. We can cut it. We get 1 is to 2. Add them. So 1 plus 2 is equal to 3. So because of the theory that C is proportional to the charge keeping the potential constant, we can say that Q1 is equal to how much capacitance, that much charge. C proportional to Q. Okay. So Q1, this was the charge of the Q1 part. So this is the ratio of the Q1 part. So one part on the total part, that is 3 multiplied by the total charge. How much? 108 microcoulomb. I repeat, one part of this branch capacitance divided by the total 3 parts. So 1 upon 3 into 108, which is the total charge. So what is my answer? 36 microcoulomb. Fine. Similarly, Q2, which is in that branch, having 6 microfarads of capacitance, which has amounted to the ratio 2. So I write here 2 divided by total. Total is 3 into 108 microcoulomb. So what is my answer here? 72 microcoulomb. So Q1 I have, Q2 I have. Therefore, charge on C1 is Q1 is equal to 36 microcoulomb. Charge on C2 is also Q1 only 36 microcoulomb. Charge on C3 is Q2, which is 72 microcoulomb. Fine. And this type of question can also have a check where Q1 plus Q2 should be 108 microcoulomb. This is a faster and easier trick to find out charge in every capacitor. There are other methods given in textbook solutions. They can also be followed if they are convenient, but I am trying to find out the charges by a faster and easier method for any series and parallel type of a circuit. For capacitors, step 1, find out the equivalent capacitance. Step 2, find out the total charge. Use the ratio method in the branches. Find out the part that contributes to the charge. 1 part here, 2 part here. We get the charges accordingly. Write down what is Q1, Q2, Q3. So I hope you have understood this method and will implement it, because this is a very fast method. Fine. Take a pic of what we have done just now so that you understand this method very clearly. So continuing the same trick of ratio method to find out the charges for a circuit with capacitance in series and parallels, let us do this question and understand what is asked and what can be done. Obtain the equivalent capacitance of the network in the figure. So they are already told us to obtain the equivalent capacitance for 300 supply, volt supply. Determine the charge and voltage across each capacitor. So what they have given is V is equal to 300 volts. Then they have already mentioned the capacitance on each of them, and you have to find out the total equivalent charge first. Then charge on each capacitor, that is the next part of the question. Voltage on each capacitor, that is another part of the question. This is the query. Now, using our method, let us find out equivalent capacitance for which. First, let us identify which are the capacitors in parallel and in series. Fine. So again, as usual, let us start from here. Okay. Let us start from here, and there is a junction here which goes this way or this way. As I said, a T junction is formed from the source after the source has started. Okay. So here we can say Q1 is the charge. Here we can say Q2 is the charge. And Q1, Q2 join together and we get Q here joined together. So meaning Q is distributed into Q1 and Q2. Agreed? So we have to find out Q, then we will distribute it into Q1 and Q2 by ratio method of capacitance. Fine? Okay. Then one more thing, they have asked us to find out the potentials also. So let us voltage also across each capacitor. So let us name the voltage here as V1. For C2, let it be as V2. This is C1. This is C2. So V1 C1, V2 C2, V3 for C3 and V4 for C4. Okay, and remembering that for a series combination charge is same, and for parallel combination potential is same. Fine. So for V2 and V3, Q1 is the charge, and for this line and this line potential remains the same. So we can write V1 should be equal to V2 plus V3 together. Fine. Okay. That is our query. V4 also we can get. So this has to be remembered. The potential in this line should be equal to the potential in this line. That's why V1 should be equal to V2 plus V3. So to find out C equivalent, let us first find out the series combination of C2 and C3. So let us name it as C23, which is equal to C2 C3 upon C2 plus C3. Okay, what is C2? 200 plus 200, multiply by 200 divided by 200 plus 200. In the end, we will write picofarad. Fine. So at present, there is no need of carrying pico. P is 10 raised to minus 12. We will write it in the end. Fine. Okay. So we get 4 upon 400, which amounts to 100 picofarad. Fine. So C23 is ready. Now C23 is in parallels with 100 picofarad because here there is a T junction. Fine. How is the T junction looking like? This way. So Q1 is here and Q2 is here. That means these two branches are in parallel. So if they are in parallel, then we can write C1, 2, 3 is equal to C1 plus C2, 3. What is C1? C1 is 100. What is C2? 3. That is also 100. So we get 200 picofarad. Fine. So this combination of C1, 2, 3 and C4 are in series. As you can see, the upper part joins with the lower part of the capacitors. Fine. So to get C equivalent, C1, 2, 3 and C4 are in series. So we write C1, 2, 3, C4 upon C1, 2, 3 plus C4. So what is C1, 2, 3? 200 into 100 divided by 200 plus 100. So that amounts to 2 into 10 raised to 4 divided by 3 into 10 raised to 2 picofarad, which amounts to C equivalent is equal to 200 upon 3 picofarad. So our first step of finding out C equivalent is done. Fine. Now, as a regular work, we will find out the total charge. Though the question is find out charge on each capacitance, let us find out the total charge and then use the ratio method to find the charges Q1 and Q2 as seen here. Fine. Okay. So now Q is equal to, our step 1 is over. This is our step 2, regular step 2. Q is equal to C equivalent V. What is C equivalent? 200 upon 3. V is 300. So 100. So our answer is 2 into 10 raised to 4 picocoulomb. Q is equal to 2 into 10 raised to 4 picocoulomb. That is our total charge. Fine. Now we will use the ratio method to distribute Q1 and Q2. Q is already with us. Fine. So we don't have to worry for Q. Okay. So let us now use the ratio method to find out Q1 and Q2 distributed in these two branches. Okay, we know C proportional to V. Sorry, C proportional to Q. Okay, so how much C? That much is the Q. So what is the ratio? C1 is to C2 3. C1 is 100 picofarad as you can see, and C2 3 from here we got it as 100. So if I cancel out, I'll get 1 is to 1. 1 plus 1 is equal to 2. So total is 2 and parts are 1 and 1. Simple. So Q1 is equal to part 1 upon total into the total charge is 2 into 10 raised to 4. So which is equal to Q1. We can cancel this out. 10 raised to 4 picocoulomb. Similarly, Q2 is also the same, one part only. So we can write 10 raised to 4 picocoulomb. So Q1 and Q2 are ready. If Q1 and Q2 are ready, Q is already there with us as 2 into 10 raised to 4 picocoulomb. So we are ready with the charges. See how quick it is. Fine. We are ready with the charges on C1, C2, C3, C4. What is the charge on C1? It is Q2. Correct? How much is Q2? 10 raised to 4 picocoulomb. C2 and C3 both have the charges Q1. So on C2 and C3, Q1 is again 10 raised to 4 picocoulomb. Then on C4, the charge is Q. So what is Q here? We had 2 into 10 raised to 4 picocoulomb. So our charges on C1, C2, C3, C4 is ready. This is Q2, this is Q1, and this was the total charge Q itself, which is 2 into 10 raised to 4 picofarad. So we are done with the second part of the question where they asked us Q1, Q2, Q3, Q4. Now we come to the last part where they are asking us V1, V2, V3, V4. So let us find out V1, V2, V3, V4. Looking at the diagram, V1 is equal to Q2. Q2 is going in V1. Q2 upon C1. What was Q2? 10 raised to 4 upon C1 is 100. So which amounts to 10 raised to 2 volts, 100 volts. We have to get the total as 300. Fine. V2 charge is Q1 upon C2. So what is the Q1? Again 10 raised to 4 upon 200, which is equal to 50 volts. This is 100 volt, this is 50 volt. V3 also has a charge Q1 upon C3, which is also again 100. that is 10 raised to 4 divided by 200, not 100, which is equal to 50 volts. Fine. V4. V4 is equal to total charge is Q divided by C4. Q total charge is 2 into 10 raised to 4 divided by 100, which is equal to 200 volts. Fine. Okay. So we are ready with V1 as 100 volts. We can write this as 100 volts. V2 as 50 plus 50, 100. So these two have 100 and 100. Fine. And V4 as 200. So 200 plus 100 total is 300 volts. Fine. Okay. Why? Because potential for parallel combination remains the same. So this is 100, this is 100 and this is 200. So this we cannot count it as separately 100 and 100. So it is 100 only. Potential is 100 only, which is going from here, and this portion is 200. So total potential difference here is 100 up and 200 down. Fine. So total 300 volts. Fine. So in this way, whenever there are parallel and series combination, use easier method. What is the step 1? Find out equivalent capacitance. Step 2, find out total charge. Use ratio method to find out the charge distribution. Using the charge distribution, substitute it here or find out the charges on each capacitors. Using that information, you can find out, because you have two variables. Out of the 3 variables, you have 2 variables. Substitute, find out. It is very easy. Okay. So I hope you have understood. I have taken time to make you understand, but once you understand this method, it will be very quick for you to follow it. Fine. So take a pic of what I have done so that this kind of a ratio method becomes easy for you to calculate charge distribution and hence the potentials across the capacitors. Okay.